Hello, emerging scholars. Welcome to this episode of Stats and Research Chats. Let's roll up our sleeves and dive into the topic of measurement. So today we're going to be talking about the 4 levels of measurement. Meltzoff and Cooper in their text, one of the texts we're using, class Critical Thinking About Research, Psychology, and Related Fields. They talk about this idea that it's important to identify the level of measurement used by the researchers and evaluate whether it's congruent with the statistical methods used for analysis. So to identify the level of measurement, you first want to know how these levels are distinguished. They're distinguished by 4 different characteristics: identity, magnitude, equal unit size, and absolute zero. So selecting a statistical test, the first question you consider in this process is the level of measurement. So let's just look through these different processes that a researcher goes through when identifying and selecting level of measurement. So chances are you have a research question in mind, and then you want to identify your hypothesis. If your hypothesis is the hypothesis of relationship or association, you might be saying, we hypothesize that there's a statistically significant correlation between your attachment relationship with your paternal attachment figure and your attachment relationship with with God. And we believe that there is a correlation between these variables. If that's the case, if that's our hypothesis based on the research on divine attachment figures, then perhaps we would hypothesize this relationship exists. If, however, we're looking at the hypothesis of difference and we're saying we believe that there is a statistically significant difference between attachment-related anxiety before someone goes through an attachment workshop and attachment-related anxiety afterwards, then we're measuring the hypothesis of difference and looking at how one group is statistically significantly different before and after treatment. And so we're going to be using different sets of statistical analyses depending on which hypothesis we're using. Another question we have to ask to know what type of statistical analysis to use is, are we using 2 measures, like a pre-test, post-test, or are we using more than 2, like pre-test, post-test, 5 months after treatment, for example, because then we might be using a different assessment like an ANOVA, depending on whether our groups are independent or correlated. Now, we need to know what our level of measurement is, because if we're dealing with nominal data and we're using the hypothesis of difference, we might use the coefficient of contingency for our statistical test. If we're dealing with nominal data and we have the hypothesis of association, or we're looking at relationship, we might be looking at something like McNemer's test, or depending on the number of measures we have, perhaps a chi-square test. So how do we figure out if we do have nominal data or interval ordinal level data? First, we want to consider the property of identity. So constructs are assigned different point values based on different properties. So for example, men and women might be assigned different values, where if someone completes a demographics assessment and identifies as a male, we might assign the number 2, and a female the number 1, for example, or Republican number 1, Democrat number 2, or any type of categorical variable. Like if we look at attachment, if we look at the firefighter style, for those who have walked through the fires of loss or abuse, they might be assigned a variable. They might be assigned the number 1. Then those who have a more anxious attachment style, who we've called the investigator in the 4 relationship styles, these individuals have keen observational skills, may have higher levels of anxiety, lower levels of avoidance. We might assign them the number 2. Then we might assign security guards a number 3 and networkers a number 4. That doesn't mean that 1 is greater than 4, that 4 is a larger value, so greater than 1, or vice versa. It just means that each number represents a different category of attachment style or relationship style. And so this is going to help determine what type of statistical analysis we can use to analyze the data, depending on what that data represents or what properties it has. So nominal data would have that property of identity. The next one we want to look at is magnitude, also known as ordinality. This is where variables are put in order by quantity. For example, class rank. So someone might have the highest GPA in their graduating class, and so they might be listed as the first in their graduating class or ranked number 1. So they would have that property of magnitude in their ranking. Equal unit size. Another property of data is equal unit size. So if we're measuring and we want to know that a difference of 1 is the same throughout the entire scale, like the difference between 4th grade and 5th grade is 1 grade. The difference between 7th grade and 8th grade is 1 grade. If I look at, let's see, my drawer, I thought I had do I have a ruler? Yes, I have a ruler here. Okay, so let's say we're looking at inches here, the top part of the ruler. So we've got the front of the ruler to 1 inch right here. So we've got that increment of space from 1 inch to 2 inches. Then from 2 to 3, we have that same increment of space. The same amount of space exists between 6 and 7. Same amount of space exists between 11 and 12, right? So wherever you are on that interval, on that ruler, you have an equal distance between increments on the scale. So 1 grade is 1 grade, 1 inch is 1 inch. The difference between valedictorian and salutatorian, excuse my pronunciation, may or may not be 1. It may be 1/10 of a point. Maybe the valedictorian has a 4.0 GPA. The salutatorian has a 3.9997, right? So it might be less than 1 unit of GPA. It might be a fraction of a unit of GPA. That makes the difference between first and second, right? But the difference between 1 inch and 2 inch should always be 1 inch. So these are a bit distinct. If we look at absolute zero as another property of data, absolute zero is defined as a property of measurement in which assigning a score of 0 indicates an absence of the variable being measured. So if you think about 0 on a test, someone could not answer any questions, turn in a test blank, or get every question wrong and earn 0 points, right? Now that's going to be different from an attachment style, right? If we have 4 different categories of attachment styles, a person who completes the relationship styles test is going to identify what the relationship style is from one of those 4 styles, rather than having an absolute 0. Wouldn't make sense to say they have 0 relationship style. We all have an attachment style. So you wouldn't have a 0 as far as the categorical component of that assessment. Now, you might have a measure of attachment-related anxiety, and if that anxiety is so low that it's rated 0 throughout, then you might have an absolute 0 representing that there is 0 attachment-related anxiety, which would be rare. Even someone who's secure would possibly have some attachment-related anxiety or some avoidance tendencies, but it wouldn't be the primary feature of their relationship style. Scale. So each of the 4 scales has one of the properties. The 4 scales include nominal, which is categorical data, ordinal, which is rank-ordered data, interval, which includes equal spaces between the intervals. Ratio has been called the mother of all scales because it includes all of the above. The numbers are say something to us about the category, the magnitude, the equal intervals between, and the absolute 0. There is that distinction between interval and ratio, meaning that on a ratio scale there would be an absolute 0, and the interval scale would include equal spaces between variables, however not necessarily an absolute 0. But the SPSS software does group both interval and ratio together because you can use often the same statistical analyses on those. So it groups interval and ratio together and calls that scale level data. So that gives you a bit of an overview of the different characteristics of the scale. In our next episode, we'll talk more about nominal, ordinal, interval, and ratio level data and the types of statistical tests that you can use with each type of data. But I hope that you have enjoyed this video, and I hope this gives you some concepts to contemplate and think about until our next meeting.